this video, we will be talking about factoring polynomials, primarily quadratics and third-degree polynomials. So to start with, we will start by finding the greatest common factor. The greatest common factor is always the first thing I check for when factoring. So for example, if I had something like 2x plus 6, and my direction said to factor completely, here I would look for a GCF, and that would be 2, and now I'll be left with x plus 3. So that would be one way to factor using the greatest common factor. Sometimes we might have an expression with two variables. You can still factor by finding the greatest common factor. So if you look here, our GCF is now 3x, and we will be left with x squared plus 4 in our parentheses. So the greatest common factor, easiest way to factor, that's the one I always check for first. The next thing I try is to factor by grouping, and I can only use grouping when I have 4 terms. So for example here, if I had 2x plus 2y plus ax plus ay, and I'm told to factor this, first I would group the first two and the last two. Now I'm going to take the GCF of this first one, which would be 2, and I'm left with x plus y. The GCF of the second one is a, so I'm going to put plus a times x plus y because that's what's left. If these two things are the same, I know that I can factor by grouping. So here I have 2 plus x times x plus y. We take the GCF, which is this, and we'll be left with 2 plus a, and that would be how we would factor by grouping. So those two are used sometimes, but the ones that are more useful would be like the difference of two squares. So like if we had x squared minus 9, and it says to factor completely, we need to think difference of squares when we see this. This is already written as something squared, but this could be written as 3 squared. So we can factor it as x minus 3, x plus 3. And if we multiply that back out, we would have x squared minus 9. This will also work if we had x squared minus 4, y squared. We still have 2 squares, and we're taking the difference. So now we would have x minus 2y and x plus 2y. And when we multiply it back out, we would only have this left at the end. You might want to try this for the sum of squares. But I'll just let you know that the sum of squares is prime. So there is no special rule for the sum of squares. It's impossible to factor the sum of 2 squares. Okay, so far we've talked about the GCF, grouping, difference of squares, and sum of squares. Now let's talk about the difference of cubes. So if we have x cubed minus 8, we see that this is something cubed, but I always try to rewrite this as something cubed also. So I have x cubed minus 2 cubed, because that's what 8 is. And then this is the formula that I always try to follow. So if we have a cubed minus b cubed, it's going to be a minus b times a squared plus ab plus b squared. So for this problem, a is x and b is 2. And we don't have to worry about the signs, they take care of themselves. So here I'm going to have x minus 2 times x squared plus 2x plus 4. And that would be how you could factor a difference of cubes. It also works the same way for the sum of cubes. So say I have x cubed plus 8. We'll just use the same numbers. Same formula here. If I have x cubed plus a cubed plus b cubed, I can factor that as a plus b times a squared minus ab plus b squared. So for this problem, a is x and b is 2. And what we'll have to do is just fill it in. We'll have x plus 2 times x squared minus 2x plus 4. So the sum of squares was prime, but the sum of cubes is factorable. So those are the main ones that people seem to get confused on, but we will review just some others. So if we have a trinomial, that means it has 3 terms, and our leading coefficient is 1. Those are the easiest ones, the ones that we like. So if we have x squared plus 2x plus 1, we're looking for the number that will add to give us this and multiply to give us this. So what I always do is set up 2 sets of parentheses. So now I'm going to have x and x. The only thing I can multiply to get 1 will be 1 times 1. And then if I say plus 1 and plus 1, that's going to give me plus 2x in the middle. So those are pretty simple, but sometimes we get some like this that might trip us up. So what I would do here, I know that I'm going to need an x in the front, and then y times y will give me y squared. And if I add both of them, I would get x times x squared plus x times y plus x times y plus y squared, which is what my original problem was.